Hi, everyone. We are now talking about Chapter 5.2, Writing Exponential Equations. This is a continuation of our last video where we solved exponential equations. In my notes that you see in front of you, we are working to create an equation that looks like y equals a times b to the power of x. Now, this is an equation that could have lots of different numbers you could put in for a and b. But generally speaking, A is going to be your starting amount or your beginning number, and B is going to be how much you're growing or decaying, or what you're multiplying by each time to change your graph. Now, this function, if you were to graph it on Desmos or your calculator, would have to go through a bunch of points that would be x comma y. And obviously, there's going to be more than one point it can go through, and it will go through. And we're going to be looking to try to make these equations using only those 2 points. An exponent rule that's going to help us to do that is going to be anything to the power of 0 is going to have to be equal to 1. So in this first example, we're going to be looking at an equation that goes through 0, 4 and 2, 36. So for the first part of our process, we're going to be taking the 0, 4 and putting 0 in for x, since that's the x part of the point, and 4 into y. So you can see that's what I've done in this step right here. Y became a 4 and x became a 0. Now, if I have b to the 0, well, we already know that's just equal to 1. So whenever there's a 1 times anything, well, it doesn't really matter. It doesn't affect anything. So that just means that 4 equals a. We've already gotten our starting amount. Now, if I were to then do the same exact thing for 2, 36, well, the 4 is already there from what we just did, but the 36 is going to go in for y, the 2 will go in for x, and we'll have this second line right here. 36 equals 4 times b squared. Now, if I have 9 after I divide by 4 on both sides, I would have 9 is equal to b squared, square root both sides. And well, that means I have 3 equal to b. So if I have a 4 equals an a and 3 equals b, well, that means I have an answer. In this case, I have a starting amount of 4. I'm multiplying by 3 every time. And I have an exponential growth equation going through both those points in example 1. Now, example 2 is a little bit step up from there, but generally the same steps. If, in fact, the first half of the problem is exactly the same. I have 0, 8, put the 0 in for x, 8 in for y, 8 is equal to a. That b to the 0 is just going away. For part 2 of the problem, I'm putting 27/8 into y and 3 into x. So that's a little bit different. Now I can divide by 8. If you do 27/8 divided by 8, well, that equals 27 over 64, equal to b cubed. Now, if you forget how to do b cubed, well, I can take the cube root of the top and the bottom if I have a fraction. Well, cube root of 27 is 3. Cube root of 64 is 4. Well, that's my answer right there. But say you weren't as comfortable with that, well, I can do this all on my calculator. So I can grab my calculator here, and I'm going to type in 27 over 8 divided by 8 first. Well, that's 0.421, or 422, I should say. And then I'm going to hit the math button, scroll down to the cube root option, and then go up to my answer there, copy it in, enter. 0.75 is my answer, which I have right here. And that means that my equation is 8 for A and 3/4 or 0.75 for B, giving me this exponential decay problem. Those two first examples are pretty similar to each other. We have one growth and one decay problem, but the steps in general are pretty similar. This second one being a little bit more challenging overall, though. So now one last problem to walk through together, which is going to have a little bit more calculator parts to it than that second problem did. But we're going to start off doing the same things. Well, we have a 0, 12. That's x and y. So if I have my equation y equals a times b to the x, well, I can put in my 0 for x and my 12 for y and fill in the rest with blue again. And so I have an equation. Well, b to the 0 is just gone. It just equals 1, meaning that 12 is my a value, my initial amount that I'm looking for. So let's do the second part now. So I have a new x of 4 and a y of 144. So I got to put those into x and y. So let's write our general version out. But we now have a 12 to put into a. So let's put in x and y, 144 and 4, meaning that we've got 144 equal to 12 times b to the 4th power. So the first thing we can do is divide by 12 on both sides, giving us a 12 is equal to b to the 4th. Well, you're not going to be able to find the 4th root of 12 just using just in your head or by hand. It's going to end up being a decimal answer. So we're just going to take the 4th root of both sides and do that right in our calculator. So we need the 4th root of 12. So if you forget, let's go through that together. So if we want to do a 4th root, we got to push a 4 first, and then the math button. We're going to scroll down to the 5th option down, and that creates a 4th root in our calculator. We just type in a little 12 and get an answer right there of 1.86. And that's going to be equal to b. We have found our growth factor. That's bigger than 1. We know that growth is when b is greater than 1. Number 2 was between 0 and 1. That's how we knew it was going to be decay. So let's write out our equation now. Y equals 12 times 1.86 to the power of x. And so generally speaking, if we think about the 3 problems we've just done, we need to use the first point and the fact that x is 0 to solve for a. And then we need to do the same thing, put into x and y, our second point, and solve for b. So let's write out those steps really quick. So steps for making exponential equations. All right, so step 1, use 0, y point in general form, y equals a times b to the x, to get a value. Step 2 would be substitute a value into general form. And then step 3, substitute the unused point into x and y from step 2 and solve for b. So that was finding an exponential equation using algebra when we needed to go through 2 specific points. You can also do this by using some graphing methods. One would be using Desmos or a calculator and doing some guess and check, and to find that answer that way. It would take much longer though. What we will do in our final video for chapter 5.2 is use exponential regression to find the exact equation that would go through the 2 points that we are given in the problem.